The second kinematics example that I'm going to have a look at now is this question, which states the velocity of an object, which is initially 3 meters to the left of the origin, is given by Vt equals 3t squared minus 2t minus 5 meters per second. Find, now there was a spelling mistake in this, so I've just fixed that up. Find the acceleration when the velocity is 0, the displacement when the acceleration is 0, and the distance travelled in the first second. Okay, so first thing, we want to find out the acceleration when the velocity is 0. So the first thing I need to be able to know is when is velocity 0. And to do that, I need to solve the equation 0 equals 3t squared minus 2t minus 5. Okay, so I could try factorising this. I'm actually going to jump straight to the quadratic formula because I've just got a feeling that I might need it. I don't know why. So it becomes 4 minus 4 times 3 times minus 5, all divided by 6, which gives me 2 plus or minus the square root of 4 times 3 is 12, 64 on 6, which is 2 plus or minus 8 on 6, which becomes 10 on 6, or negative 6 on 6, which is equal to negative 1. Okay, now it's pretty fair to say that the time will not equal negative 1 seconds, so the solution that I need here is 5 on 3. And I'm even going to say exclude t equals negative 1. Okay, so we know the time when the velocity is 0, so if I want to find the acceleration at this time, the first thing I'm going to do is find an equation for acceleration, which is equal to the derivative of the velocity, which is 6t minus 2, and then at a of 5 on 3, we end up with 6 times 5 on 3 minus 2, which is 30 on 3, which is 10. Take away 2 is equal to 8, and our object is travelling in meters per second, so it's meters per second squared. Alright, so that is part A complete. In fact, this was all part of part A, so I'll put that over here. Second part of the question, the displacement when the acceleration is 0. Alright, so now I need to know when the acceleration is 0. I have an equation for the acceleration. It's equal to 6t minus 2. So if I want the acceleration to equal 0, I can solve that equation to get t equals 1/3. And I want to find the displacement. Alright, so I've got an equation for the velocity, and I know that the velocity is equal to the derivative of displacement with respect to time. It is 3t squared, I've got to remember that equation now, minus 2t minus 5. So if I want to find out what x is, I can find the integral of 3t squared minus 2t minus 5 with respect to t. And I can go a little bit further here. I'm trying to find an equation when t is equal to 1/3. And I know initially, my question tells me initially it's 3 meters to the left. So if assuming that right is the positive direction, right of the origin is the positive direction, I'm going to say that this here is the point where x equals -3 and t equals 0. So I can use that definite integral trick here and say I want to find this at 1/3, and I know when t is 0 the x value is -3. Okay, so let's now anti-differentiate, which gives me t cubed minus, not a 2, it's got to be t squared minus 5t between 1/3 and 0, take away 3. So this will give me the position at t equals 1/3. Alright, so I need 1/3 cubed minus 1/3 squared, take away 5 times 1/3. That's the first part of my definite integral. Second part's going to be 0 minus 0 minus 0, and then we've got minus 3 at the end. So that is 1/27th, take away 1/9 minus 5/3, take away 3. If I get a common denominator here, 3/27ths minus 5 times 9 is 45 27ths, and then I need 27 times 3 is 81 27ths. That's a lot of 27ths. 1 take away 3 is minus 2, minus 45 is minus 47. So minus 47 on 27, take away 81 on 27. I had to write that down because I couldn't do it all in my head. And then minus 47, I'm going to do minus 40 take minus 80 is minus 120, minus 7 take 1, so it's minus 128 divided by 27. Okay, finally for part C, the distance travelled in the first second. What I could do here is I could find out an equation for the displacement, draw a graph of that equation, and then calculate what the total displacement is in that first part. I could also take some shortcuts and just assume that the particle is always travelling in the same direction in that first second. But I've got to be a little bit careful, because like we saw in one of the previous questions, if the direction changes in that time, then to find the distance I have to add the values for when it's going down and for when it's going up. So rather than drawing the whole graph, I'm going to try and be a little bit clever here and take some shortcuts. The first thing I know is that it is initially 3 meters to the left, so that means the displacement is initially at -3. The second thing I found is that the velocity is equal to 0 at 5 on 3 and -1. So the velocity is equal to 0 at those points. They will be the turning points for the displacement graph. So I can really draw a quick sketch here. I know that at t equals -1 and t equals 5 on 3, I'll have turning points for those two equations. For those 2 points, and I know that it travels through this point at x equals -3. So my cubic graph would have to be a positive cubic graph, because when I anti-differentiate 3t squared minus 2t minus 5, I get a positive cubic. So that means it's going to look something like this. So with that graph, if I want the first 1 second, I can see that my graph is always going down, And if I want to work out the distance between those 2 points, I just need to work out the change from the initial x value at -3 to the displacement when t equals 1. Alright, let's work with that then. Let's find the displacement when t equals 1. And I haven't got my equation yet for displacement at t equals 1. So I might jump back up to this expression up here, and I am going to find out what the displacement is at t equals 1. And of course this would be much quicker on a calculator, but we've just done that by hand so far, so let's keep going by hand. So that gives me t cubed minus t squared minus 5t between 1 and 0 minus 3, which gives me 1 minus 1 minus 5, take away 0 minus 0 minus 0, take away 3, which they cancel out, and I've got minus 5 minus 0 minus 3, which equals minus 8. So the change in displacement equals the distance, which is equal to -8 take away -3, which equals -5. And because it is distance, we can say therefore the distance travelled in the first 1 second is 5 metres. There you go. So a couple of shortcuts there to avoid graphing at all when looking at the graphs.